So in order to differentiate between gram-positive and negative bacteria, we are going to use a method that is going to take advantage of the thickness of the cell wall. Therefore, if the cell wall is thick enough, we are going to retain something called crystal violet. And gram staining is when you take the bacteria in the lab condition, under lab conditions, and you're going to stain them using the methods I'm going to show you in a second, in order to see if the crystal violet is going to stay, the dye is going to stay inside or not. Now we have 5 main steps when it comes to the colorization of the cell wall of the bacteria itself. First of all, let me do a quick recap for what we did last lessons. Gram-positive has a much thicker cell wall comparing to the gram-negative. We want to take advantage of this fact, and we are going to dye it with a different color, with a specific color that is basically going to be trapped inside because of the thickness of the cell wall. Because it is trapped inside, you are going to have you will be able to distinguish between the gram-positive thick cell wall and gram-negative thin cell wall. The first thing we have to do is something called fixation. We basically take the bacteria, we put them on a slide, and we heat it up pretty quick. Then the heat up above a flame is going to fix and to stick, and the bacteria is going to adhere to the actual glass. This is the first step we always need to do, because in the next step we are going to wash it, and the bacteria has to be stick to the glass, otherwise we will just lose the bacteria. The next step, after we fix the bacteria to the glass, is going to add a color called crystal violet. And crystal violet is positively charged, and it's going to be associated with the plasma, with the cell wall and the bacteria. Now, under the microscope, all of the bacteria, the positive and the negative, are going to be dyed and colored with this crystal violet. So now all of the bacteria are purple under the microscope. Then we are going to add iodine, or something called light stable iodine. Iodine is negatively charged. It is going to be associated with the crystal violet, and basically it is going to create crystals that is going to create a more solid and stable structure of the crystal violet. It's going to allow it to stay inside. So now we have a crystal violet with iodine as well. This is the third step. So first one was to fix the bacteria to make it stick so it won't wash away. Second one was to add the color, the main color, which is called crystal violet. The third one is to add iodine, which is negatively charged, and it's going to be associated with the crystal violet. Then a very important step. Now we are going to use something called decolorize. We are going to use usually an alcohol solution, and we are going to wash away the color, the dye from the slide, from the glass, from the bacteria. You're going to see that the bacteria with a thin cell wall is going to lose the crystal violet, but the bacteria with the thick cell wall, the crystal violet is going to be associated with the cell wall, and because we have such a thick cell wall, it is going to be basically trapped inside. So now we can distinguish between the gram-positive and gram-negative. However, the gram-negative now lost the dye, and it's very hard to see them. And the gram-positive it's very easy to see them. But we want to see the gram-negative as well. So now we are going to use something called saffroning. Saffroning is a color that is basically going to dye the gram-negative bacteria in pink. And now under the microscope, we will be able to see the gram-negative in pink and gram-positive in purple. We do it because it's very cheap and very easy in hospitals to see this way if the patient has a specific disease. Especially in hospitals, there is a lot of common diseases and bacteria that it's very cheap to know and to basically recognize, diagnose, and treat. So we use this cheap method in order to allow us to recognize the following bacteria under the microscope using the following technique. So gram-negative steps for the IMAT and BMAT, gram staining, is very, very important. And if I recap the video and I'm going to mention the most important steps, and the things you need to know for the exams is the color of each step of each gram positive and negative, and if the steps themselves. So let's go one by one. Fixation, they are still transparent. Crystal violet, they are all purple. Let's do it in purple. If I'm going to find it, because I can't see colors. Iodine, still purple. Washing away and decolorize using alcohol, now the gram negative is transparent, but the gram positive is purple. Counter strain using saffroning, now it will be pink, but the crystal violet is still trapped inside, so it will be purple as well. Sorry for the different color, it's the same. Imagine it's purple as well. And this is basically the steps you need to know when it comes to gram staining. I hope this video made sense. Make sure to read the notes and memorize the steps. It's very high yield for the IMAT and BMAT exams.